Hello guys and girls, welcome to the computing workshop. I am the mad computer scientist and this is my workshop. Today we are going into part 2 of our Go programming language and microservices review or intro, if you will. In part 1 we looked at installing Visual Studio Code and we looked at installing the Go toolchain, setting up a workspace, and how the workspaces are structured. Now in part 2 we will go into the syntax of the Go programming language, take our first steps in that, learning how Go how you in Go how you can do some of the basic stuff like any programmer needs to be able to do, like declare variables, how to assign variables, how can you create a function or a subroutine in Go, and also how can you use pointers, because like C, Go has pointers, which means that you can pass, unlike Java, which is for instance, it's passed by reference. Uh, Go is like C, you can pass either by value or by reference. Now, if you want to get into an argument why Java is always passed by reference, then this is not the video for that, but I will be happy to have that argument because I know I'm right. Okay, so moving on to bring up our editor here, and I've prepared some parts here just created in our workspace like we were discussing in part 1. Your workspace goes in the src folder, like you can see here in my terminal window that it's command window. You can see that it's in my workspace and then it's under Go src, and now I've named this program vars, so I created a source file called vars.go. And we will look at first variables to hold values and to work with values. Any programmer should hopefully know what a variable is, and how Go handles this. I also, you can see there's parentheses that I've added here because we have multiple imports. So unlike in part 1, we had only included the FMT, I think. Now we also have strconv, or to convert to, maybe we did that in part 1 as well, I don't remember. But anyhow, multiple imports, parentheses like this. So, and we will use these to print later on, just to print our values. Now I will not, to bore you with my typing, I will just paste some sections and then we will go over them as we go along into this source file here. I will just plug in some sections. So starting with section 1 on variables, let's add this. And now let's go over what's going on here. So here you can see the typical Go declaration of a variable, and unlike C, which would be like int my var here, we do var and then we do my var, which is the name of the variable, and we set the type at the end. So we say that this is an int. You can also see whatever types that is. You can have different types. You also have different floats, 32-bit, 64-bit precision. You have various. You can look up what types that Go supports. You can have string as well, like this, which is also a type. But let's go with an int, which looks like this. This is an integer, so this will hold an integer, and then we can of course set the variable that we just declared. So this is how to declare the existence of a variable. Use the var keyword. Then you can later on assign to this variable, and assign is the equal sign, just like in C. So we can say that my var is now equal to 1, so this will now hold 1, the integer 1. In Go, you could also do this. You could do here we add together. This is type a sort of type inference that's going on here. You say with the colon equal sign, you initialize a variable of a suitable type. Note that Go is still a safe language in that it's not like Python, that if this you can have any the variable is general holder. In this case, it will actually initialize a variable that can hold the value on the right hand side. So in this case, we tell it to take, we want a new my second var, and we're telling it by colon equal that we want to assign immediately to this new variable the value of 12.5. Now Go, the compiler, will infer from this that to store this we need, this is a floating point number, it's a decimal number, so it has a decimal sign, so it will create a, as you can see here, this will become a float. This is actually quite nifty with this colon equals, because it now, however, this value is a float after this. So unlike loosely typed languages, you cannot suddenly assign a string to this after this colon initial initialization and assignment, because now the type is set. This only helps to automatically infer. This is excellent when you are returning from something from a function and you don't really know exactly what it is. You can have this you can do colon equals to, you don't have to bother with knowing the exact type until later on. Also saves on typing. This is and gives cleaner code, I think. So this colon equal is automatically it's initialize and assign. Okay. So, and it will infer the type from whatever is on the right hand side. That's what you have to remember. Now, these are the basic operations of variables, and you can of course compare them to each other. You can do arithmetic on them, like plus or something. We'll see this later. You can do plus, minus, you can do division, you can do all kinds of things on an integer variable, and pass them around to functions. So like variables work much like you would expect, and this is the way you declare them. Now looking at part 2, and now we get into the pointer stuff. Okay, so this is the interesting pointer stuff. Like if you are a C programmer, you're probably aware of pointers. If you're a Java, C# programmer, not so much. In that those languages does not contain the concept of a pointer in that sense, whereas Go does. And a pointer points to, it's a type, it's a data type of its own, but it actually holds the address of another variable, a reference to something in memory. Okay, and in C, this is usually a bit of a danger involved in that C needs you to free the memory. What you are pointing, if the pointers can leak, and especially if you dynamically declare memory using pointers, you can have memory leaks and so on. Go actually has garbage collection that also keeps track of pointer references, which is much better than C and C++ handling of this. So it's a safer way to still use pointers. Now, and the way to use a pointer, the point of having a pointer, the point of a pointer, if you wish, is here we can declare a pointer just like we declared the existence of a variable. In this case, the type is star int. This is like C. We tell him that we tell the compiler that we want a pointer to an integer. We want to point to a memory address that contains an integer value. Then, just like C, we assign this new pointer to, and this, the ampersand, this is the address of. So we want to assign this to the address of this myvar, which now contains the value of 1. Okay. If we were to compile and run this, which we can do if we want to print then the value. We can just show that this and then the way to get the value of a pointer. Now if you wanted to print, you need to have the star in front, just like in C, to dereference the pointer. And by dereferencing, it means that you want to have not because the value of this pointer is the address of myvar, right? It's the memory address, it's not the value itself. By dereferencing, by adding this, when we send it to a function, and this is the strcom.i2a function, it converts an integer into a string, so we can print it. Okay, so the value gets converted into a string value, so we can print it. But we need to dereference the pointer, right? So by dereferencing, we are saying that we want to go to this memory address and we want to get whatever it's pointing at, not the value of the address of this variable. We want to get the actual value that is contained at that address. And this is just like in C. It's the same syntax as in C. So if we compile this, we can actually see, we can show by running go build and then running var, so we can see that it's, sorry, didn't save that. Now I got a problem. Okay, so it's because I declare this and don't use this. Just I actually, like I said, it doesn't allow. I had an older version of the program. Let's do. Yeah. Okay. Here you can see one of the interesting things of the Go compiler is that, like the imports, you are also not allowed to. It actually gives you a compiler error if you have a variable, a value which you only assign and then never use in code. So this is, the compiler actually throws an error on this. It doesn't want to compile code that contains a variable that is set but never used. This is it's very strict, but in the end it helps you find and remove stuff that is unused. So it wants us to use that pointer or that value, the floating point value, but we will do that now in the next part anyway, so let's just paste that. Okay, here I wanted to show you what will happen if you do this colon equals with this, and we set the ampersand with the address of, and in this case this floating point value. Now you will see that it will automatically infer that this is a pointer, right? So it will be a pointer to a float. So it works, the colon equals works with sending an address of something as well, and then it automatically creates a pointer, right? So now we can show that we can use this pointer to increment the value of what is pointed at. So here you see that we print what it is first, and then we use plus equals. This is also like C, this is allowed. You can do plus equals and so on, minus equals, um, this is equal to left hand side plus 2, which in this case it increments the value by 2. And this we do by using, instead of doing my second var plus equals 2, which is this value, we put the star like in C to dereference. We tell it we don't want to increment the address. We want to increment the value at this address. So we put the star there to dereference, and then we say that this value, we want to increment this value by 2. This will then change, seeing as my second pointer is a pointer which is actually pointing at this value, my second var. This means that when we print my second var, you will see that we can use the pointer to manipulate this value as well. And this is a bit of a crash course basics on pointers, and every C programmer should be familiar with this, and it works the same basically in Go. So now if we build it, still not okay, didn't save the file, sorry. Now if we build it, let's see, okay, now it works. So now we type vars, and here we can see from the first printout that we have here, we can see that we print my var, and then we print the value of my pointer, which should be the same. Yep. So my var is 1, and the pointer that points to the address of my var will, when dereferenced, give the value at that address, which is of course 1. My second pointer here will point to my second var, which is this floating point value, and now we will see what happens with pointers. Now we first have 12.5, which is the initial value, but then we use the my second pointer to increment this value at this address that this is pointing at. So we can see that now it's 14.5, even though we don't print this one, we print the value that we pointed at. So we can use the pointer to access the value, the underlying value at that address. There's a lot of other stuff you can do with pointers. You can increment them, you can decrement them. They're hugely important for certain types of data structures that you're probably familiar with if you're a C programmer, like the linked lists and various type of queues, which is easier to implement when you have the pointer type, and Go has the pointer type. So, as you can see from this example. Now let's look further into this and also into functions. So this is the basics of variables and pointers to variables. Okay. Now let's erase all of this, and then let's see how functions are declared. Functions or subroutines, or whatever you want to call them, things that you can call from code, that you can pass values to and receive a return. Now I have an example of this, what this looks like in Go. So let's just clean this up a bit. After pasting, we may want to clean this up. I'm using a snippet program that adds a shortcut here to Visual Studio Code that I'm using to keep various snippets like this to save typing, and not to bore you too much. Go, when it comes to this, is actually not right because this shouldn't be there. And this should be here, I think. Yep, this looks better. Okay, so like we saw in the main function, func declares a function. So func is always the denominator for a function. Then we have the name of the function. Then we have the values that we can pass into the function, which are values that these are the arguments. So we pass arguments, and then, unlike say C, we after this at the end we have the return. So this is what will be returned, what we expected to be returned from the function. And then we have the return keyword, which is just like in C, declares our return. But if you're a C programmer, you will see something weird happening here. This one you could probably follow along with. It's just that this has moved over here from here, basically. But this, however, Go has support for multiple returns. And this is quite interesting, because what we're saying here is that we will take a value as an argument, but we will return two integers in this function. This is, as you may know, not possible in C. However, here it's fully possible to declare like this, and then with a comma separate two separate returns, which you can then handle in code, or you can ignore one of them. I will show this later on. This is quite interesting because this allows you to have a bit more flexibility. Especially this is the way that Go, you can, for instance, have a return which is basically an integer or something, and you can return maybe your own data structure or record type that has your error information if something goes wrong or so on. This is the normal way that error handling is actually handled in Go, which you will see in a part further along in this series. But it has multiple returns, and that's quite interesting. So first we will try to pass something. I want to show what happens when we do pass by pointer, or pass by reference, if you will, as opposed to pass by value. So when we pass by reference, we accept a pointer to something. So we say here that our argument, and once again the type is in the opposite way from the from the name of the argument, just like it puts the type at the end. You want you to put the data type on the end, so it's in reverse from, let's say, C. So and in this case we say that we want to have an argument that we call val, and this is a type of pointer to an integer, so we will accept the pointer to an integer here, or in this function we will have a pointer to an integer. So we want to return two integers with using a multiple return, so we want to then increment the value pointed to by this pointer, as we saw just recently in the variables part of this this session. So we take the value pointed to by this pointer and we increment it by 1, which is plus plus, and then we return the value, okay, and a 0, just to show how multiple returns work. Here we could use maybe an error code or something. If something went wrong, we could have maybe a custom data structure for that, which we returned here. And then we have pass by value, where we instead have something that is not a pointer but an actual value. So here we accept an integer value, and then we return a single int, which looks like this, instead of a multiple return, which looks like this. Okay, so we have a single return value, and then we just increment the value itself and we return the value. But now you will see what happens with pointers, which could be something new to you if you come from a background in certain languages. I will show how this is used. Let's use these functions. Okay, so here we have a lot of statements. um, I'll show you. um, so in main we added, okay, so we do value. Here we just set up a variable to implicitly this will become an integer, as you can see, with the colon equals automatically typing it to an integer. And then we have something called retval. We can see that colon equals also works on the return of a function call, because now we're calling the pass by pointer function. We want to execute the code in this function and want it to run it on this value. So now we give it, since this one accepts a pointer to an integer, sets up a pointer, we pass the address of value. This is also just like you would normally do in C. So you pass the address of this variable. Okay, now you will see what happens to value, this one, which is declared inside the main function when we pass the pointer. Because now, as we are passing a pointer, we are actually manipulating this value inside the function. So now the return will be incremented by 1. But that also means that this original value, this copy of value that we have here, will also be incremented by 1, because we are incrementing what we are actually pointing to, that address in memory. We are incrementing that value. But when we pass here, we set this again to pass by val, which we pass the value itself. Now we actually passing a copy of this value, which is 1, and setting this up here as a not a pointer but an actual variable, an integer variable, not a pointer to an integer, which means that now we increment what was passed in and we return the result, right? But this is now local to this function. And this is just like in C, this is the difference between passing by reference or using a pointer and passing by value. So now we are copying the value into this, and then we're incrementing it and returning it, meaning that we will return something is incremented and we return the incremented value, but this value, when we then print the local value inside the main function, it will not have increased, because this value is then destroyed after the return. So we pass back the value of this integer and then we destroy it, meaning that nothing happens to, we're actually not manipulating this value itself. So this is and here you can also see another point worthy to note is that here you have the multiple return in action, because here we are also using this underscore character, and you can use that when you have multiple returns to tell the compiler that you want to ignore the one of the return values. You could move this over here instead. Now we know that this one returns the value we want in the first return value, so we set this to the first one, and then we use the underscore to declare that we want to ignore the 0 that is returned. We don't want to do anything with that. This is for blanking out values you're not interested in when you have multiple returns. You use the underscore like this and a comma sign. You could have also have a second variable here, an integer variable, and then it would have assigned this first value to this and the second return value to the second variable. So that's how you use multiple returns, and you can, as you can see, you also use that with the colon equals construct. So now you're starting to see some of the power in that is in Go, and the type of syntax it uses. So now you have now we can test run this and see what happens. So let's run it and see what happens. First, let's build it, and that works fine. And now Okay, maybe I should, before building it, we should save this file. Now let's build it after saving the file. Now type vars, and now as you can see, because we used, because we first we passed in 1, so the return value is of course 2 because we are returning this incremented. But now you can see that the original value in the main function also changed to 2 because we used a pointer to actually increment the value at that address. Now, however, when we pass by value, as we do here, the return is now 3, which is 2. It was 2, and now it's 3 because it was incremented. Okay, so what we return is the value 3, but the original variable here, which we now print, is still 2 because we didn't pass, we passed a copy of this. We use a local copy of this that it gets assigned the value that we pass. So we pass the value of 2, we increment that, and we return 3. But then the original variable at this address that the value has is not changed, so it's still 2. That should give you a basic crash course understanding of how pointers sort of work. If you come from a language that have a background in programming languages that doesn't use pointers, unlike C and C++, where this is very similar to how it's done in C and C++ using pointers, and Go retains this capability. So now we have seen how we can do how we can work with variables. We can assign values. We can use the colon equals construct to automatically initialize and assign, set the type also of a variable. We can also use pointers. We've seen how we can use pointers, and we've also seen how the function construct looks in Go, how you declare functions or subroutines that can take parameters and return values. And we also looked at the multiple return, which is an interesting construct, which is, as you start using it more, if you come from like a C background, you actually find that it having multiple returns, especially for handling errors and so on, and passing error information, is actually quite useful. So that's it for this part. So see you in part 3, where we will probably look at some loops and basic and records or data or structures. So bye for now.